Hello, 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 guys. My name is Desmond, and I welcome you to my lesson for today. Ladies and gentlemen, please do allow me to say it's very much important that I say it's very, very much important, ladies and gentlemen, because what I'm about to say, it's massively important. So, good people, a day without learning something new, it's a day wasted. Guys, at all times, please do make sure that by the end of each and every lesson that I do, you learn something new. Okay, so ladies and gentlemen, for today's lesson, we'll be looking at Doppler effect. Okay, so I assume it's not your first time hearing about the word Doppler effect. So this is a chapter under physical sciences, paper 1, where we'll be looking at moving cars relative to listeners or observers. Ladies and gentlemen, you should ask yourself this type of questions. What exactly is Doppler effect? As you can see, ladies and gentlemen, I've tried to draw by hand an ambulance over there. You've got two friends over there. There's a formula, and you've got some waves around an ambulance. So, ladies and gentlemen, by the end of this lesson, you should be able to fully interpret and understand what I've actually drawn over there. Okay, and most importantly, you should be able to fully understand this chapter as a whole. So, I would encourage you, if possible, to just spend much of your time listening to what I'll be writing and listening to what I'll be saying. Most importantly, ladies and gentlemen, if you are able to listen and write at the same time, it's still okay. You can do that. But if need be, you can just listen to what I'll be saying and take into consideration what I'll be writing. I'll make sure to have this lesson available at all times so that you can play it over and over again until you fully understand. Okay, so good people, Doppler effect. What exactly is Doppler effect? So, ladies and gentlemen, I'm mostly interested in explaining to you exactly what is Doppler effect. Very, very much important, ladies and gentlemen, that you understand this type of concepts. Okay, so in short, the Doppler effect is the change in frequency or pitch of the sound, or the color of light that is detected when the source and the observer move relative to each other. Ladies and gentlemen, I'll quickly write that information down and break it into pieces so that you fully understand what we mean by Doppler effect. Okay, so guys, I've just explained to you that Doppler effect is the change in frequency or pitch of the sound or the color of the light that is detected when the source and the observer move relative to each other. Okay, so ladies and gentlemen, please don't mind my handwriting. I suppose you're good enough to listen to what I'm saying, and I assume you can write better than I do. So you'll just listen to what I'll be saying, and with your neat handwriting, write down your own notes. Okay, so ladies and gentlemen, if I was in an exam room, or if I was writing a test and I have a question where they want me to define Doppler effect, this is the definition that I would give to say Doppler effect is the change in frequency or pitch of the sound or color of light that is detected when the source and the observer move relative to each other. Okay, so in this case of Doppler effect, we'll be focusing mostly on sound as compared to light. So there's a chapter that will also do some time as time goes on, where we'll be focusing on light. But for now, let's focus on the sound. Okay, so ladies and gentlemen, we've got some keywords that we use mostly as far as Doppler effect is concerned. As you can see on my definition, I've got a frequency, and again I've got a observer. What else do I have, ladies and gentlemen? I've got a source. Okay, very, very much important, ladies and gentlemen. So guys, can I just write down these keywords? So let me say keywords. Okay, I've just spoken about frequency and observer. Let me also add a source. Okay, very, very much important, ladies and gentlemen. So when we talk about a frequency, in the simplest term, ladies and gentlemen, we're actually talking about how often. Okay, how often. That's basically what we're talking about when we refer to the frequency. How many times per second, how often does whatever happens? How many times per second does whatever that we're talking about happen? That is the frequency. How often does it rain within a year? Okay, so in 2000, in 2001, 2002, 3, 4, 5, up until let's say 2005, we can compare how many or how often it has rained each and every year when comparing these 5 years, from 2000, 2001, 2002, 2003, 2004, and 2005. So when we talk of frequency, we talk about how many times has it rained per year. Okay, so in this case, we are talking of frequency relative to the wavelengths. So I'm going to get into that as we continue with the lesson. So ladies and gentlemen, we also talk about the observer. Okay, so what are we talking about when we say the observer? Ladies and gentlemen, this is the person who hears or sees. Obviously, in terms of seeing something, that's when we talk about light. But in this case, because we'll be focusing on sound, then it means it's a person who hears the sound. Okay, so in short, let's say an observer, it's actually a person. Okay, person who hears a sound. Very, very much important, ladies and gentlemen. What are we talking about when we talk of the source? Okay, so in terms of the source, ladies and gentlemen, this is it could be a car it could be an aeroplane, it could be myself as I'm speaking now. What am I doing, ladies and gentlemen? I'm emitting sound, okay? I'm emitting sound. So, that means I'm the source of the sound that you hear as an observer. So, as far as Doppler effect is concerned, we want to calculate the frequency of that sound. Okay, so guys, at all times, please make sure that you read to understand. Okay, and most importantly, at all times when you read, please try to have a visualization of what you're reading. And again, try to come up with a good interpretation of whatever that you'll be reading about. Okay, so ladies and gentlemen, I'm just quickly going to explain to you what happens when a car approaches a listener. Ladies and gentlemen, who is the listener? A listener is the observer. Okay, what does the observer do? The observer is the person who hears the sound. Okay, so guys, I want us to check what happens when a car approaches a listener. Okay, so ladies and gentlemen, let me just quickly draw a very beautiful car over there approaching a, let's say, an observer. Okay, so ladies and gentlemen, what matters the most in this case is that this is a car which is moving in that direction. Guys, obviously when a car it's moving, it has a speed, okay, of which we can refer to that as a velocity. Okay, so obviously, ladies and gentlemen, because we are talking about two things. What are those two things? It's the source and the observer. Okay, it doesn't necessarily mean that only the source will be in motion. Okay, there are some instances where you might find that the source is moving and again the listener is moving. It doesn't matter in which direction, but what matters the most for now is that you might have both the source and the listener moving. Okay, so ladies and gentlemen, it's best for us to actually differentiate the velocity of the source and the velocity of the listener. So guys, how about we refer to the velocity of the source, which could be a car, which could be a train, which could be an aeroplane, as velocity of the source. Okay, good people, let's refer to the velocity of the observer as velocity of the listener. Okay, of which it could be a human being, it could be an animal, it could be a detector, whatever device which may be used to record the sound. Let's refer to that as velocity of the listener. Ladies and gentlemen, remember guys, you might be having an animal moving in a particular direction relative to the source. Okay, you may be having a detector within a car moving in a particular direction. Okay, so you should be open-minded about this chapter, ladies and gentlemen. A lot of things can happen. For now, it's just a matter of comparing multiple situations. Okay, so ladies and gentlemen, what happens as this police car, which is emitting sound from its siren, what happens when it approaches that observer or listener? Ladies and gentlemen, we've got what we call the wavelengths. Okay, we've got what we call the wavelengths. So think of this as a spring, ladies and gentlemen. You've got a spring over there. Let's say this is a spring. So obviously, ladies and gentlemen, when this car approaches the listener, it's more like this spring is being compressed. Okay, you can just imagine that when this car is somewhere there, that means this spring will be compressed such that the waves in between, they are closer to each other. Okay, so let's assume these are the wave lengths. Okay, so obviously just think about this, ladies and gentlemen. You've got a listener, you've got a car, in between you've got a spring, and now assuming that this listener is actually standing and not moving, and it's only the source which is moving, so you can see you're compressing the spring. Okay, so ladies and gentlemen, what does it mean? It means the wavelengths are becoming shorter and shorter as the source approaches the listener. Okay, so ladies and gentlemen, there's a relationship between the wavelengths and the frequency. Okay, there's a very good relationship between the two, and the relationship is that the frequency is inversely proportional to the wavelength. So that means as the wavelengths become shorter, ladies and gentlemen, the frequency, it obviously becomes longer. Okay, or the listener receives higher frequency. Okay, so you just need to understand that between the two there's an inverse relationship, such that when the other one goes high, the other one goes lower. Okay, so very, very much important, ladies and gentlemen, that you understand what I'm trying to explain. Okay, so obviously, ladies and gentlemen, the opposite is the truth when a vehicle moves away from the listener. Okay, so assuming that you had another listener on this side, so this car obviously approached that listener, and now it's moving away, approaching the other listener. So now what happens as it moves away, ladies and gentlemen, from that listener? So that means the wave lengths are becoming larger. Okay, so obviously it means the opposite is the truth when it comes to the frequency. Okay, so for you to easily understand, ladies and gentlemen, for you to easily understand, obviously when we talk of the pitch, we refer to the sound. Okay, so you can just think of the noise being made by this source. Obviously, as the source is approaching you with its siren on, you're obviously hearing a lot of noise, isn't it? So why are you hearing a lot of noise? It's because as this source is approaching you, the frequency is high. Okay, so that means the wavelengths emitted by the source are becoming shorter and shorter as the source is approaching you. Okay, so in terms of the pitch, that means you receive a higher pitch. Okay, so that means ladies and gentlemen, in terms of the pitch relative to the frequency, they are directly proportional to each other. The higher the pitch, the higher the frequency. The higher the frequency, the higher the pitch. The higher the pitch, the higher the frequency, the lower the wavelength, or the shorter the wavelengths. Okay, so with regards to the source moving away from the listener, Ladies and gentlemen, it then means the pitch it's now becoming lower. Obviously, as a police van is moving away from yourself, the noise starts to decrease. Okay, so that means the frequency it's going down, the pitch is going down, but in terms of the wavelengths, okay, the opposite is the truth, because these two are inversely proportional to the wavelength. Okay, so that means you're having longer wavelength. So this type of questions, this type of information, ladies and gentlemen, it's only to help you in case where you are not required to perform any calculations, but to tell whether the situation will remain the same, greater than, or less than. Okay, I assume as we continue with answering the questions, that's when you'll be able to then realize how important this information is. Okay, so ladies and gentlemen, in short, I'll just quickly explain to you over there what happens. So guys, this is what is happening. You've got an ambulance over there. Okay, you've got an ambulance approaching let's say observer B, and this will obviously be observer A. Okay, so this is what we refer to as the source. Okay, so ladies and gentlemen, this is the source of sound. Okay, obviously because this source is moving in that direction, ladies and gentlemen, that means you are having compressed spring. Okay, so that means in short, the wavelengths are becoming smaller, okay, or shorter. So guys, please allow me to write smaller over there to say the wavelengths are becoming smaller and smaller. Okay, so guys, that means we're having a shorter wavelengths on this side. That means we're having shorter wavelengths on this side of listener B. Okay, and again, what else are we having, ladies and gentlemen? That means we're having higher frequency. Very, very much important, ladies and gentlemen. What else have we got on this side of that source? Actually, between the source and the listener, in a situation where the source is moving towards the listener who's standing at that point. The other thing that we're having is a higher pitch, ladies and gentlemen. Very, very much important that you take into account this information that I'm providing to you guys. So, ladies and gentlemen, that means as this source of sound is approaching a listener who's standing there, you are having a smaller or shorter wavelengths. Just like I've tried to explain in terms of a spring. So it's more like a spring, it's being compressed, and as it's being compressed, that means a higher frequency, higher pitch, more noise. Can we just add, ladies and gentlemen, to say more noise? Okay, very, very much important, ladies and gentlemen, because this information helps you to visualize what happens when the source approaches a listener. Guys, what happens on this side of the source where a source of sound is moving away from listener A? Okay, ladies and gentlemen, the opposite is the truth. Can I just say it so that it remains your opportunity to write these notes, which is obviously the opposite of what I've written on this side of the scenario. Ladies and gentlemen, on this side, that will mean you are going to have a, larger wavelengths. Okay, so this is the opposite of what you'll be having on this side, larger wavelengths. Okay, so in short, ladies and gentlemen, it means if you are having shorter wavelengths on this side, then you'll be having longer wavelengths on that side. Remember, guys, remember, we are talking of wavelengths. Okay, so this is from one wave to another. Okay, can you see how long is that wavelength? This is the wavelength from one wave to another. Can you see how long is that wavelength, ladies and gentlemen? Okay, so let me also just nicely draw that wavelength. Ladies and gentlemen, can you see how long is that wavelength from that wave to the other? Okay, this is in comparison with the wavelengths on this side, ladies and gentlemen. Very, very much important that you understand that it's actually a comparison of a situation where the source of sound is approaching and moving away from the observer or the listener. Okay, so ladies and gentlemen, it's very, very much important that you understand that in most cases we'll be talking about the source and the observer or the listener. Okay, very, very much important, ladies and gentlemen. So just think of anything which is moving and emitting sound relative to something which is detecting sound, of which in most cases we refer to a human being, because in real life, on our daily basis, we do come across situations where an ambulance is rushing to an accident scene. Ladies and gentlemen, in some instances, we use trains to travel. Okay, not only those two, but also especially in Gauteng, where you've got a lot of public transports, calling passengers making use of the hooter. Then in that case as well, you observe Doppler effect. Okay, so ladies and gentlemen, let's compare the frequency in this situation versus that situation. Okay, so obviously that means we're going to have low frequency. Okay, we're going to have low frequency. Why? Because you're having longer wave lengths. Okay, so if we are having low frequency, what does it mean in terms of the pitch, ladies and gentlemen? So that means you're also having a low pitch. Why are you having a low pitch? It's because frequency and pitch are directly proportional to each other. Okay, so when the other one goes high, the other one goes high. When the other one goes low, the other one also goes low. Okay, very, very much important, ladies and gentlemen. Unlike the two, when you compare with the wavelengths. Okay, so that means that's when we talk of two quantities being inversely proportional to each other. Okay, so ladies and gentlemen, in short, or in simplest terms, in terms of the noise, what does it mean? So that means you hear less noise as the source of sound is moving away from yourself as the observer or as the listener. Okay, very, very much important, ladies and gentlemen, that you understand this information. Okay, so guys, from this you've just noticed that I've actually indicated that we've got velocity of the source and velocity of the listener. Okay, so again, we've got, remember guys, the frequency as a result of the source. Okay, so we also do the same and refer to this as the frequency of the source, which is the frequency emitted by the source. Okay, very, very much important, ladies and gentlemen. So again, we have the frequency registered or heard by the listener. Okay, obviously when you're standing there, because you are being approached by a source of sound, you will obviously register a sound. Okay, so we refer to this frequency as the frequency of the listener. Okay, very, very much important, ladies and gentlemen. Guys, the sound emitted moves through the air. Okay, very, very much important, ladies and gentlemen, that you understand that the sound emitted by the source, its medium is the air. Okay, so that means the sound needs to travel through the speed of air. Okay, so ladies and gentlemen, we also have a V, which refers to the velocity of the velocity of the sound, or the speed of the sound. Okay, so ladies and gentlemen, what I wanted to explain to you is that the sound emitted by the source, it also has a speed. Okay, and that sound travel through the air. Okay, so I hope I've explained it correctly such that you are able to fully understand. Okay, so ladies and gentlemen, we just refer to the speed of the sound as v. Okay, remember, speed and velocity refers to the same thing. The only difference is that velocity is a vector quantity and speed is a scalar quantity. Okay, so the difference is, in terms of the speed, it doesn't have any direction, it's only the magnitude. In terms of the velocity, it has both the direction and the magnitude. Okay, very, very much important, ladies and gentlemen. So now, to differentiate between the velocity of the source, the velocity of the listener, and again the velocity or the speed of sound, we just made use of that S over there to say this is the velocity of the source, this is the velocity of the listener, and a V represent the velocity of the sound. Okay, very, very much important, ladies and gentlemen. So we make use of these quantities 1, 2, 3, 4, and 5 to derive that formula, ladies and gentlemen. Okay, very, very much important. I'm just quickly going to give you the hint in terms of how to successfully use that formula. Okay, so guys, I'm just going to remove some of this information. I assume you fully understood what I was writing there. And again, ladies and gentlemen, most importantly, I've just indicated that I'm going to have this lesson available so that you are able to make your own notes. Okay, so for now, let me remove this part of the information. So remember, guys, you just need a glass of water. I think we can just make use of this opportunity to just quickly have a glass of water. Okay, so ladies and gentlemen, I'm going to talk a little bit more about that formula. Okay, I'm 100% sure when I write FL, you know exactly what I'm talking about, which is equals to, ladies and gentlemen, we want to know, as the source of sound is approaching a listener, how much of noise are you actually registering in your ears. Okay, that's exactly what we want to find out when we use this formula. So whatever that you hear, ladies and gentlemen, it's as a result of frequency of the source multiplied by the V, plus or minus VL over V plus or minus VS. Okay, ladies and gentlemen, I'm standing wherever I'm standing. Okay, so now there's a car, ladies and gentlemen, which is making a lot of noise. Okay, so that car which is making a lot of noise, it's, it could be approaching myself or moving away. Okay, and also I could be moving in that direction or in that direction, or otherwise just standing at that point. So I want to know, ladies and gentlemen, in a case where this car is approaching me, how much of noise is this car making? Okay, in a case this car it's now moving away, ladies and gentlemen, how much of noise am I registering in my ears? Okay, in a situation where this car is approaching me and I'm also approaching this car, how much of noise am I registering, ladies and gentlemen? In a situation where this car is moving away and I'm also moving away, how much of noise am I registering in my ears, ladies and gentlemen? Very, very much important, ladies and gentlemen, that you are able to understand the situations in which this chapter is concerned. Okay, so that means you may be asked in an exam multiple ways where the listener and the source are moving in different directions. Okay, so ladies and gentlemen, I've just indicated to you that this refers to the frequency of the source. Guys, at all times, please be aware that we've got what we call the SI units. Okay, so the SI units is the international symbol that we use. It's actually the units in which we represent these quantities. So frequency, it's measured in hertz, ladies and gentlemen. It doesn't matter whether it's the frequency of the source or the frequency of the listener. For the fact that it's a frequency, then it's measured in hertz. Okay, very, very much important, ladies and gentlemen. What is this, guys? What is this, guys? What is this, guys? What is this? I've just explained to you that V refers to the velocity. Okay, so what is the SI unit for the velocity? The SI unit for velocity is meters per second. It doesn't matter whether it's the velocity of the sound, whether it's the velocity of the listener, whether it's the velocity of the source. What matters the most is that we know velocity is measured in meters per second and frequency is measured in hertz. Okay, so that means we've got two quantities over there. Okay, where one quantity may refer to the listener observer and the other quantity may refer to the source. Okay, very, very much important, ladies and gentlemen, that you understand these formulas. Okay, guys, you should ask yourself, why am I having a positive and a minus over there? Why am I having a positive and a minus over there? So, ladies and gentlemen, this is just a general formula. Okay, it's just a general formula representing multiple situations. Okay, so guys, I'm going to give you this which is regarded as a secret, but it shouldn't be a secret because it's a valuable information which can help you to excel in your exams. Okay, ladies and gentlemen, when the source, okay, or the listener it's moving towards, or it could be the source moving towards, and again it could be the listener moving away, or the source moving away. You need to know whether to write a positive over there or a negative over there. Okay, very, very much important, ladies and gentlemen. So remember, at the top we talk about the information related to the listener. Okay, so that means in terms of the velocity of the listener, in terms of the velocity of the listener over there, ladies and gentlemen, when the listener is moving towards, okay, when the listener is moving towards, then you use a positive. Okay, so let's say positive towards. Let's say positive towards. Okay, very, very much important, ladies and gentlemen. So obviously when the listener is moving away from the source, then you use a negative sign. Let me just say away. Okay, very, very much important, ladies and gentlemen, that you fully understand the information that I'm explaining to you over there. Okay, so ladies and gentlemen, let's now talk about the velocity of the source. Okay, so let me just say V of the source, because I've realized in most cases most of my learners, they get confused in terms of which sign to use over there. Okay, so this lesson is here to fully explain to you which sign you use and for what reasons. Okay, so ladies and gentlemen, I hope at this stage you are not really confused, you are not lost, we are still together, we are still on the same page. So please, ladies and gentlemen, if you're still watching this lesson at this stage, that means you really appreciate the information that is being provided. And for that reason, ladies and gentlemen, I'm humbly requesting that if possible, please do give me a feedback so that I'm able to, have an idea whether I'm not confusing you or if I'm confusing you, ladies and gentlemen. But otherwise, I assume we are all on the same page. So, guys, moving to the velocity of the source. Okay, so what happens when the source is moving away? Okay, or should we follow the same order as we did over there, ladies and gentlemen? So that means what happens when the source is moving towards. Okay, so if the source is approaching a detector of the listener, ladies and gentlemen, you use the opposite sign. Okay, so you use minus. So let's say towards. Okay, very, very much important, ladies and gentlemen. So that means obviously it's a positive when the source is moving away. Okay, so guys, I assume with this information that I've provided so far, you fully understand this chapter, Doppler effect. Okay, I can tell you, ladies and gentlemen, I can promise you now that you will have a full understanding the moment we start solving questions related to Doppler effect. Okay, I'm going to make sure that you fully understand, and most importantly, that's where you're going to explore some additional information, because what I've just given to you now is just a general information. So for us to make sense, we need to solve past exam papers. Okay, so ladies and gentlemen, thanks for joining, and I hope you enjoyed this lesson as much as I did. So guys, my name is Desmond and I'm out.